Good morning, everyone, and respected teachers. My name is Manikant Reddy uh, from Cybersecurity Section A. So, in this subject Python programming, I want to explain what is NumPy. Okay, let's go into video and discuss about it. What is NumPy? Yes, what is NumPy? NumPy is a Python library. A Python library. NumPy is used for working with arrays, and NumPy is short for numerical Python. Okay, here see the slide. Okay, and what is NumPy? Actually, what means by NumPy? NumPy is a Python library used for working with arrays. Yeah, in the first slide also we saw NumPy is used for working with arrays, and it also has functions for working in a domain of algebra, linear algebra, for Fourier transform and matrices. Okay, and NumPy was created in 2005 by Travis Oliphant. Okay, the NumPy is a Python library actually. So it was created in 2005 by Travis Oliphant. Okay. It is an open source project and you can use it freely. NumPy stands for numerical Python. At the core of NumPy package is an array object. This encapsulates an n-dimensional arrays of homogeneous data types with many operations being performed in a compiled code for performance. Okay. Yeah. How to install NumPy in a PC or a computer or any. Okay. First, we'll see that if you have a Python or VIP already installed on a system, then installation of NumPy is very easy. So here you have already downloaded or installed Python IDP or PIP. It's very easy to install NumPy also. If not install Python, some process is there. I will show how to install. Okay, install it using this command in Command Center or Windows PowerShell. Okay, here is there. You can use this and install NumPy. Okay, if it is already installed, then it will show the requirement is satisfied. Okay, next we will see another slide. Import NumPy. Once NumPy installed, before slide we saw that how to install NumPy and all these. So now once NumPy installed, import it in your applications using the import keywords. Here ideally shell can see this how to import NumPy and all other. So okay, next we will see another slide. Yeah, applications of NumPy. Okay, here first application of NumPy is maintain minimal memory and mathematical operations. Second one is mathematical operations, and third one is NumPy with pandas. Okay, NumPy with Skype and alternative for list and multi-dimensional arrays and arrays application and NumPy with matplotlib and NumPy with Thinker. Okay, these are all applications in this slide. It is very easy to understand what applications of NumPy and all these. Oh, yeah. See that? Sorry, just Abhitag will see that what is NumPy, how to install NumPy, and how to use. But here, question is why we use NumPy. Okay, let's see. Uh, in Python, we have lists that serve the purpose of arrays, but they are slow to process. Okay, in Python, we have lists that serve the process of arrays, but they are slow to process. Okay, uh, NumPy aims to provide an array object that is up to 50x faster than traditional Python list. NumPy is very fast and 50x faster than traditional Python list. So that's why we'll use that NumPy. Normal, ideally, Python is a little bit slow when we use NumPy. The array object is NumPy is called an array. It provides a lot of supporting functions that make working with an array very easy. Okay? Arrays are very frequently used in data science where speed and resources are very important. Okay, in data science, slow to process is not required. It's required speed. So the people use this NumPy for speed and resources. So okay, these are all why we use NumPy means these are all reasons. Okay, NumPy maintains minimal memory and arrays in NumPy are objects. Python deletes and creates these objects continually as per requirements. Okay, uh, NumPy maintains minimal memory. If you use a laptop, it contains some memory like 126 GB or like that 1 TB or yeah, something GB. So you have lots of files and so much of memory. But here you have to do work in some projects and they storage and for PC storage or maximum memory required. So when we use an NumPy, it's maintain a minimal memory. That's why we'll use that NumPy. Okay, Python deletes and creates these objects continually as per the requirements. Whatever required, that only will create, and not required objects will delete it. So NumPy main applications. Sorry, main use of these points. Okay, you can also create multi-dimensional arrays in NumPy. These arrays have multiple rows and columns. Okay, working with NumPy also include easy to use functions for mathematical computations on the array data set. Okay, NumPy is easy to use. It's not difficulty and it's very fast than traditional Python list. Okay, and it's maintain a minimal storage or memory or okay. And Python, whatever requires, it only save and unwanted materials it was deleted. So we get an answer, no? Why we use a NumPy? Here all the reasons and in the slide. We get uh, what is NumPy and how to install NumPy and why we use NumPy. Only these three questions get clear about NumPy. Okay, just we'll look into further and dive into deep about NumPy. Okay, NumPy applications with other libraries. NumPy with pandas. Okay, one of the application I will show you. One of the application of NumPy. Let's see here. Here is a NumPy. NumPy with pandas. This is the sixth application of NumPy. So we'll look at. We will look. Okay. NumPy with pandas. Pandas is one of the most important library in a Python for data analysis. Pandas provides high performance, fast analysis, and data cleaning. We use it to manipulate data structures and have data analysis. Okay, here NumPy with pandas. Pandas is the most important library in Python. Okay, for data analysis. For data analysis, it is very important with NumPy with pandas. Here is a picture you can see and understand. Uh, Next, we'll go into another slide. NumPy with matplotlib is a module is a in NumPy. It's a module in NumPy. It's very easy. It's very helpful tool to work with graphical representations. It consists wide range of functions to plot graph and also manipulate them. Okay, here we'll use that some graphical representation. It is very used uh, in NumPy. Okay, matplotlib. Next, NumPy with Tinker is a standard library for GUI. We use Tinker for GUI representation. The NumPy data. Its combination with NumPy can implement faster and easy GUIs. The use of Tinker is also NumPy is user friendly. We can easily convert the array objects into image objects. Why is NumPy faster than less? Normal Python is very comparatively slow, but when we use a NumPy, it's 50x faster than normal. Okay? But here is the question is why is a NumPy faster than less? NumPy arrays stores at one continuous place in memory, unlike lists. So process can access and manipulate them very efficiently. Okay, can understand in this point why is NumPy faster than list? Okay, this behavior is called locality of reference in a computer science. This is main reason why NumPy is faster than list. Also, it is optimized to work and with latest CPUs architecture. Nowadays, people use want that easy to work. So if system is or any function are going slowly, your work will maintain slowly. So people want speed. So these are all requirements in present days. So everyone use this NumPy, and so it will speed the work. Which language is NumPy written in? Which language is written in NumPy? Okay. NumPy belongs to which language? We have coding. We have many languages like C, C++, or Python and Java, JavaScript, or so many are there. But from starting onwards, NumPy, what is NumPy? All these things we are discussing. But which language is NumPy written in? NumPy is Python library, and it is written partially in Python, but most of the codes that require fast completion are written in C or C++. Okay, it belongs to Python library only, but some parts for computation are written in C and C++ language also. Okay. NumPy creating arrays. NumPy creating arrays. Creating a NumPy and array object. Just see example. Import NumPy as a NP array. NP array. Here is a list 1, 2, 3, 4, 5, and print a ARR. Print type of ARR. What type of data output is? Okay. And access arrays elements. Array indexing is the same as accessing an array element. You can access an array element by referring to index number. Here is the index number. I will show one example and explain it. The indexes is in NumPy array start with 0, meaning that first element has the index 0 and second one has the index 1. Example, get the first element from the array. Import NumPy. This first line is very important. Then only it will applicable. And suppose if first line is not there, it will not work whatever you write. Okay. ARR np dot array. Here is the list 1, 2, 3, 4. Print ARR index number is 0. 0 for what? First number, first element. First number is there. That shows index number 0. 1 for 1 index number is 0 and 2 index number is 1 and 3 index number is 2 and 4 index number is 3, like uh, index number start with 0 only, not for 1. It's so many people confusing that index number start with only 1 like that, but it's wrong. When you type here 1, you want 1 first element you want, but your index number is 1, but it shows 2. It's not it's wrong. Index number start with only 0. Slicing arrays. We'll look at into slicing arrays. Slicing in a Python means taking elements from one given index to another given index. We pass slice instead of index like this: start, colon, end. We can also define the step like this: start and colon, end, colon, step. We'll see. Just now we said that the index numbers and the same as if you don't pass start, it's considered 0. If we don't pass end, it considered length of dimension. If we don't pass step, it's considered a 1. Slice elements from index 1 to 5 on the following arrays. What output is given? 2, 1 means one index number means here second element, and fifth element means here 0, 1, 2, 3, 4, 5. This last will not include. Before that will include. So here output is 2, 3, 4. Okay. So we will look at into another slides about NumPy. What is NumPy? Here, data types in a NumPy. Okay. NumPy has some extra data types and refer to data types uh, with one character, like I for integers, U for unsigned integers, etc. Below list of all data types in NumPy and the characters used to represent them. I for integer and B for Boolean, U for unsigned integer, F for float, and C for complex float, and here is the symbol small m time delta, and capital M for date time, and O for object, and S for string, U for Unicode string, V for a fixed chunk of memory for other type or void. Okay. Now just suppose you know some basics of Python. You only know about integer and boolean and float and string. These much only you know, but you learn something about Python or anything. You're deep in any code language. You know all this integer, boolean, unsigned integer. You all know about this. But if you learn only something little bit, you know, first basic integer, boolean, float, and string. These much only you know. Okay, just look at into this. Okay. Checking the data type of an array. The NumPy array object has property called dtype. that returns the data type of the array. Example, get the data type of an array object. Import NumPy as np array. np.array, here is a list 1, 2, 3, 4. Print arr dot d type. Here output is what type, that input type what. Uh, yes. NumPy array shape. Shape of an array. The shape of an array is a number of elements in each dimension. Number of elements in each dimension. Get the shape of an array. Okay. NumPy arrays has an attribute called shape that returns a tuple with each index having the number corresponding elements. Example, print the shape of 2D array. Here, shape means what is yeah, use shape. What does it mean? The shape of an array is number of elements in each dimension. Each dimension, how many number of how many elements are there? So here is a code source, and you can answer. Okay, try it once and NumPy array reshaping. Just now, backside slide is this other shaping NumPy array shaping. Now we'll see that reshaping arrays. Okay, reshaping means changing the shape of an array. Just now, shape of an array we learned. Now reshaping means changing the shape of an array. Is one shape is there, and changing from one shape to another shape. The shape of an array is a number of elements in each dimension, right? And by reshaping, we can add or remove dimensions or change the number of elements in each dimension. Reshape from 1D to 2D. Okay. Example. Convert the following 1D array with 12 elements. 12 elements, right? Into 2D array. The outermost dimension will have 4 arrays, each with 3 elements. The outermost dimension will have 4 arrays and each with 3 elements. Now, array reshape, 4 arrays. Outermost 4 arrays, and each of array have 3 elements. Here we'll see that 4, 1, 2, 3, 4 is one outermost dimension. Okay, sorry, each with 1, 2, 3 is a one dimension. Okay, and 4, 5, 6 is a one dimension. 7, 8, 9 is a one dimension, and 10, 11, 12 is a one dimension. How many we got? 4 arrays we got, and each of array, how many we got? Three elements we got. So that's here is a code. Import NumPy. Here first line is very important. We will not suppose we didn't take this, it will not work. Okay. Array np dot array. Here is a list 1, 2, 3, 4, 5, 6, 7, 8 up to 12. And new new array arr dot reshape into 4 outermost dimensions, comma 3 each of them. Print new r. What output should be what? First we discuss now. For arrays, outermost arrays will get, and each of them will get 3 elements, right? Next, NumPy array iterating arrays. Iterating means going through elements one by one. As we deal with a multi-dimensional arrays in NumPy, we can do this using basic for loop of Python. If we iterate on 1D array, it will go through each element one by one. Okay. Here we'll see that example. Iterate on the elements of the following 1D array. Import NumPy as an np. array. NP dot array. Here is the list. 1, 2, 3. For x in array, print x. Means what? It, first we'll read that definition. Iterating means going through elements one by one, right? One by one. As we deal with multi-dimensional arrays in NumPy, we can do this using basic for loop. Starting only we learn that for loop, while loop is there. No? Here we use that for loop of Python. If we iterate one dimension, right, it will go through each element one by one. For x in array, print x means what? Output should be what? 1, 2, 3 is a separate one, right? NumPy joining arrays. Joining NumPy arrays. Joining means putting contents of two or more arrays in a single array. In SQL, we join tables based on a key. Where areas in NumPy, we join arrays by access. We pass a sequence of array that we want to join the concatenate of function along with its axis. If axis is not explicitly passed, it is taken as a 0. Okay. Import NumPy as an M. Here is a code source. We'll see and what output you must write. Okay. Import NumPy as an NP. First array arr1 np dot array. Here is a head 1, 2, 3 array arr2 np dot array 4, 5, 6 is one source and third arr dot n first combine two arrays, right? Here what is the topic? NumPy joining arrays. There is the two arrays are there and joining two arrays. Okay. Np dot concatenate array 1 and comma array 2. Here print arr means both will combine. One output should be what? 1, 2, 3, 4, 5, 6. Joining of two arrays. NumPy splitting array. Splitting NumPy arrays. Splitting means what? Divide. Okay. This must be just simple language. Splitting means what? Divide. Joining means what? To combine. Splitting is reverse operation of joining, right? Here, just see that what we'll see here. Two arrays are splitted already. Now, what will we do? Combine two arrays. Now, what we'll do? One array is there and split. Okay. Splitting is reverse operation of joining. Joining merges multiple arrays into one, and splitting breaks one array into multiple. Yeah, it's divides breaks on not only two or three or four or five. It's not about it's not possible only means what? Not only two, it also multiple breaks also will possible. We use array underscore split off for splitting arrays. Okay, we pass it the array we want to split and the number of splits. Example, split the array into three parts. This array is there and split into three parts. Import numpy as an np. Arr dot np arr equal to np. Here equal to what? Here equal to assignment operator. This is called assignment operator. Np dot array. Here is the source 1, 2, 3, 4, 5, 6. New r np dot array underscore split arr comma 3. This is there and this is the array. This divides into three parts. Print a new array. Means what? 6 elements are there. Here divides into three parts. Means what? 1, 2 is an one array, and 3, 4 is an one array, and 5, 6 is an one array. That's it. We'll see into it more. NumPy searching arrays. Searching arrays, you can search an array for certain value and returns index that gets a match. To search an array, use where of method. Here you understand that NumPy searching arrays. Here we'll see that example and understand clearly. Find the index where the value is 4. Finding element in an array. How to find that? We'll see. Import NumPy as an NP. Arr dot np dot array. Here the source 1 2 3 4 5 4 4. X equal to np dot where of NumPy searching arrays main. How to search. Here is the source where of arr equal to double equal to 4. This double equal to is called relational operators. Okay, print x where it will show the index numbers only. Okay, NumPy filter arrays. Filtering arrays getting some elements out of an existing array and creating a new array out of them is called filtering. In NumPy, you filter an array using a Boolean index list. A Boolean index list is a list of Booleans corresponding to index in the array. Okay. If a value at an index is true, then element is contained in the filter array. If the value at that index is false, that element is excluded from the filtered array. Okay. Creating an array from elements on index 0 and 2. So what check it, import NumPy as an NP. Thank you so much everyone. Okay.